What if I told you that the math required to potentially debunk Albert Einstein's greatest theory isn't, well, it isn't some incomprehensible multi-page calculus equation.
Right.
It's actually just, the kind of basic addition and subtraction you'd use when you're figuring out how fast two cars are passing each other on the highway.
Yeah, I mean, it sounds almost absurd when you frame it exactly like that.
It really does.
Because we are so conditioned to believe that paradigm-shifting physics requires just completely impenetrable mathematics.
Exactly.
But the critique we are looking at today uses fundamental, just inescapable geometry to try and pry open a crack in the foundation of modern science.
Welcome to the deep dive. Today we have a really specific, honestly fascinating source text to explore with you. It's an excerpt translated from a document that has, I think, one of the most provocative titles I have ever seen in a scientific critique.
Oh, absolutely.
It's titled Draft 2, Mr. Einstein Slacking 132 Case by Case.
Just this title alone tells you we're in for really serious intellectual confrontation here. Yeah.
Slacking.
Right. The word slacking implies that the most revered physicists of the 20th century didn't just make a casual error.
Right, like he forgot to carry the one.
Exactly. It implies he perhaps took a deliberate mathematical shortcut. That he ignored something crucial.
And our mission today is to step directly inside this complex physics thought experiment that, frankly, dares to challenge that legacy. Now, just to be clear up front, we aren't taking sides here.
Right, of course not.
We're just impartially unpacking the author's claims. We are going to explore a hypothetical scenario involving a completely stationary camera, a speeding train, and light signals.
A classic physics setup.
Yeah. And the goal is to understand a proposed fundamental flaw in the special theory of relativity.
Which is huge.
Right. So whether you are a physics buff or just someone who loves a good intellectual underdog story, this deep dive is going to completely reframe how you think about speed, perspective, and questioning so-called settled science.
It really forces you to look at things differently.
So let's set up the board for this thought experiment. Where exactly does the author position us to watch all this unfold?
Well, the text establishes a really absolute rigid baseline. It asks us to imagine a camera eye. That's the term they use.
Okay, a camera eye.
Yeah, and this camera eye has a velocity of exactly 0, and it's suspended within what the text calls Maxwell's electromagnetic field.
Okay, let's unpack that really quick just to make sure we aren't glazing over the terminology.
Sure.
When the source mentions Maxwell's electromagnetic field, we aren't just talking about like an empty void of space, are we? We need to understand the environment this camera is sitting in.
That is a really crucial distinction. So in the mid-19th century, James Clerk Maxwell unified electricity and magnetism.
Right.
And physics conceptualized this field as the invisible medium, or sort of the fundamental rule set through which light waves travel.
So it's like the underlying grid of reality.
Exactly, it's the grid. So when the author places the camera eye in this field at a velocity of 0, they are establishing a fixed absolute coordinate system.
I keep thinking about this in terms of video game mechanics.
Oh, I like that. How so?
Well, imagine you are playing a massive, incredibly detailed open world game, right? And you enter spectator mode.
Okay, yeah.
You detach your camera from your actual player character, and you just float there in the sky. You have this, like, God camera.
Right, you're just observing.
Yeah. You are an unmoving, absolute point of reference, perfectly suspended in the invisible grid of the game's code. You're just watching the universe happen around you from perfect stillness.
That spectator mode analogy captures the essence perfectly because, starting with a velocity of 0 is a profoundly bold philosophical move by the author.
Why is it so bold, though?
Well, in the post-Einstein world of modern physics, the concept of an absolute universal stillness is generally completely discarded.
Oh, because of relativity.
Exactly. Relativity teaches us that everything is relative to everything else. You are sitting in a chair right now, so you feel still. But the Earth is spinning, and the Earth is orbiting the sun, and the solar system is moving through the galaxy. Modern physics argues there is no true absolute 0 velocity anywhere.
Because there's always Like a bigger Russian nesting doll of motion that you're trapped inside.
Precisely. But this source text demands that we stop. It anchors us.
It forces a hard stop.
Yeah. It resurrects the concept of absolute space and demands that we establish this camera eye at a true absolute zero velocity within the electromagnetic field.
Okay.
And establishing this stationary perspective sets the stage for the entire conflict to come. It forces you, the listener, into a fixed reality before we introduce any motion whatsoever.
Okay, so the camera is locked in place, recording the invisible grid. But a camera needs a subject to film, right?
Right.
The absolute stillness is only important because it gives us a baseline to measure something that is actually moving.
Exactly. And that is where the author introduces our test subject.
Which the text refers to as the interferometer inertial system.
Yes.
And I am definitely going to need you to translate that because interferometer inertial system sounds like a prop from a 1950s sci-fi B movie.
It is a very dense term, I'll give you that, but it breaks down into two very practical concepts. First, an inertial system simply means a frame of reference that is moving at a constant velocity.
So no speeding up or slowing down.
Right. It is not accelerating, it is not hitting the brakes, it is not turning, it is just cruising in a perfectly straight line.
Got it. And the interferometer part.
An interferometer is a highly sensitive scientific instrument used to measure the properties of light.
Okay.
It works by splitting a beam of light, sending those beams along different paths, and then bouncing them back together to see how they interfere with one another. It's basically the ultimate tool for measuring light speed and motion.
Okay, so the author is putting this massive light-measuring laboratory into motion.
Yes.
The text actually offers us a slightly more, I guess, poetic alternative name for this. It calls it the Earth Train.
The Earth Train, right.
Yeah. So I'm visualizing this sleek, high-tech, perfectly sealed bullet train rocketing endlessly to the right.
Yes, and the text specifically designates to the right as the positive x-axis.
The positive x-axis, right. And the source states this Earth train is moving at a speed of 0.6 c. So that is 60% the speed of light.
Which is an unimaginably fast speed.
Yeah, that's wild.
But remember the definition of an inertial system we just talked about.
Constant velocity.
Exactly. Because it is moving at a perfectly constant velocity of 0.6 c, if you were inside that sealed train with no windows, you would not necessarily feel the sensation of movement.
Right, like being on an airplane.
Yes. If you poured a cup of coffee on that train, the liquid would pour straight down into the cup. Within the walls of the train, it acts as its own enclosed world, its own localized reality.
But we aren't inside the train pouring coffee. We have to stick to the rules the author gave us.
Right, we are the camera eye.
We are floating in spectator mode at absolute zero, watching this incredibly fast Earth train blast past us from left to right along the positive x-axis at 0.6 times the speed of light.
That is the exact setup. And now that the board is set, the source demands a shift in our focus.
Okay, where to?
We have observed the train from the outside. Now, the author requires us to look at the space inside the train to see how light signals behave based on their direction of travel. This is where the geometric friction really begins, and it all revolves around what the text calls apparent speeds.
Okay, let's dive into those apparent speeds, because this is where my brain tripped a massive alarm when I was reading the source material.
Oh, not surprised.
The text lays out two very specific scenarios for light signals inside the space of the moving Earth train.
Right.
First, if a light signal inside the train is moving forward, meaning it's traveling in the same direction the train is traveling, along that positive x-axis, the apparent speed is listed as 0.4 c.
Yes, 40% the speed of light.
Right, so that is the forward apparent speed.
Okay.
But then the text flips the direction. If a light signal inside the train is moving backward, meaning it is traveling against the direction of the train along the negative x-axis, the apparent speed is listed as 1.6 c.
Yes.
And the text really underlines this. It highlights the absolute necessity of distinguishing between these two directional apparent speeds.
The author treats this distinction as absolutely paramount.
But wait, hold on, stop.
What's wrong?
1.6 c, as in 1.6 times the speed of light.
Yes.
The speed of light is the cosmic speed limit. Einstein famously established that absolutely nothing can exceed 1.0 c.
Right.
Are you telling me this author is casually claiming we can observe a speed of 1.6 and we are supposed to just, accept that? How does the author justify breaking the ultimate law of physics?
It is a brilliant question, and honestly, representing that exact skepticism is why this thought experiment is so compelling.
I mean, it feels like a typo.
It does.
Yeah.
But to understand how the author justifies 1.6c without actually breaking physics, we have to strictly apply the logic of the camera eye we established at the beginning.
Okay.
We cannot abandon our post in spectator mode. We are watching from the absolute outside.
Okay, my camera is still locked at 0 in Maxwell's field.
Good. Now, consider the actual speed of light. Light travels at 1.0 c. That is its baseline, absolute speed propagating through the electromagnetic field.
Right. 1.0 c.
The Earth train, meanwhile, is moving to the right along the positive x-axis at 0.6 c.
Okay.
If a scientist inside the train fires a laser beam toward the front wall of the train, which is also moving to the right, we essentially have a foot race.
Oh, I see. The train is essentially trying to outrun the light beam it just fired.
Exactly. From our stationary God camera perspective outside the train, the laser beam is moving to the right at its absolute speed of 1.0 c.
Right.
But the front wall of the train is moving away from that laser beam at 0.6 c. So from our unmoving perspective, how fast is that laser beam actually closing the gap and gaining ground on the front wall?
Okay, the geometry is clicking for me now.
Yeah.
The light is doing 100%, but the target is running away at 60%. So the light is only gaining ground at a rate of 40%.
Right.
That's the apparent speed of 0.4 c moving along the positive x-axis. It is the relative closing speed between the light and the wall.
That explains the 0.4 c perfectly. It is just a simple matter of geometric subtraction from an absolute perspective.
Okay.
Now, apply that exact same geometric logic in reverse.
Okay, so the scientist goes to the front of the train.
Right, and fires the laser beam toward the back wall. The laser beam is now traveling to the left along the negative x-axis at 1.0 c.
Right.
But remember, the back wall of the train is hurtling to the right, plunging toward the laser beam at a speed of 0.6 c.
Oh, so they are rushing head-on toward each other?
Yes. From our stationary spectator camera outside the train, we see the light moving left at its constant 1.0 c, and we see the wall of the train moving right at 0.6 c.
Right.
So the speed at which that specific gap is closing, the apparent speed at which the light is crossing the train's internal space from our absolute vantage point, is the combined speed of those two objects.
Which is 1.0 plus 0.6, giving us the 1.6 c. That is wild. So it's not that a physical photon of light is actually breaking the universal speed limit and traveling faster than it should.
No, not at all.
It's just the combined closing speed of the light and the train wall, observed from our completely stationary outside perspective.
The moving walkway at an airport is actually the perfect way to ground this concept in everyday reality.
Oh, I love that. Let's expand on that.
Go for it.
Imagine an incredibly fast-moving walkway at the airport, right? It's moving forward at 6 miles per hour. That is our Earth train.
Okay.
You are the light beam, and your natural walking speed is always exactly 4 miles per hour.
Right.
If you get on the walkway and walk forward in the same direction it is moving, a person sitting stationary on a bench nearby, which is our camera eye.
Right. They're watching from the outside.
Exactly. They see you flying past at 10 miles per hour, your speed plus the walkway speed.
But if you turn around and try to walk backward on that exact same moving walkway against the flow of traffic, the geometry completely changes for the person on the bench.
Right. You are walking 4 miles per hour backward, but the floor beneath you is carrying you 6 miles per hour forward.
Yes.
To the stationary person on the bench, you are actually moving forward. Wait, you're moving backward at an apparent speed of 2 miles per hour.
Exactly. The gap between you and the end of the walkway is closing at a completely different rate.
Because the direction you walk fundamentally changes the mathematical reality for the observer on the bench.
And that is the absolute crux of the author's mathematical setup.
Okay.
The source stresses this main mandate. We must strictly distinguish between these directional apparent speeds within the interferometer inertial system.
Right, inside the train space.
Yes. The apparent speed moving forward on the positive x-axis is 0.4 c. The apparent speed moving backward on the negative x-axis is 1.6 c.
And we have to keep those separate.
Emphatically, they are not the same. They are mathematically asymmetrical, and the author is absolutely adamant that any valid, truthful physical theory must account for this mathematical reality as observed from the camera eye.
Which brings us to the moment where this document pivots from just like a purely mathematical exercise into a direct indictment of the greatest physicist of the modern era.
Right.
Because these apparent speeds, the 0.4 c and the 1.6 c, are the entire basis for the author's ultimate argument.
This is where the title of the document, Mr. Einstein's Slacking, finally reveals its full meaning.
Yeah, they're going for the throat.
The author is moving to expose what they view as a critical failure in logic.
The text concludes by urging the reader to pay close attention to what it boldly calls a specific defect in the special theory of relativity.
A defect.
Yes, and that proposed defect is the fact that special relativity completely excludes or simply ignores these direction-dependent apparent speeds within the train space.
To really grasp the weight of this accusation, we need to understand why Einstein would exclude those apparent speeds in the first place.
Right, he wasn't just being lazy.
No, we need to look at what special relativity actually postulates, because Einstein didn't just forget to do the math. He built a system that deliberately discards the God camera.
Break that down for us. Why did Einstein throw away the absolute spectator mode?
Well, special relativity is built on the principle that the laws of physics are the exact same for all observers in uniform motion.
Okay.
Essentially, Einstein argued that if you are inside that enclosed, windowless Earth train moving at 0.6 c, you have no physical way of knowing you are moving.
Right, the coffee pours straight down.
Exactly. Therefore, the speed of light must measure exactly the same for you inside the train as it does for someone standing still on a platform outside.
Okay.
Einstein postulated that the speed of light in a vacuum is absolutely constant for all observers, regardless of their own motion or the motion of the light source.
So if I am the scientist inside the Earth train and I fire the laser beam forward, Einstein's theory says I will measure that light traveling away from me at exactly 1.0 c.
Yes.
And if I turn around and fire the laser beam backward, Einstein says I will still measure it traveling away from me at exactly 1.0 c.
That is the core of relativity. It states that the universe contorts itself, time literally slows down, and space literally contracts to ensure that the local observer inside the train always measures the speed of light as 1.0 c.
Oh, wow.
By making that rule universal, relativity essentially dictates that there is no absolute stationary vantage point.
It just doesn't exist in his model.
Right. It claims the 0.4 c and 1.6 c apparent speeds we calculated from the outside are totally irrelevant to the fundamental physics happening inside the train.
So Einstein smoothed over those messy directional differences.
He did. He smoothed them over to create an elegant, universally applicable law where light speed never changes for the person measuring it.
Man, when you really sit back and look at the philosophical friction here, the audacity of this document is just stunning.
It really is.
To look at the cornerstone of modern physics, a theory that has passed countless experimental tests for over a century, and say, you missed something here. You deliberately ignored the underlying geometry. You slacked off.
Well, the critique is rooted in a fundamental, irreconcilable difference about what actually constitutes reality.
How so?
The author is arguing that by smoothing over or excluding these internal directional apparent speeds, special relativity misses a critical piece of the puzzle. It sacrifices mathematical truth for theoretical elegance.
Because the author demands an absolute reality.
Yes. The author demands a reality anchored by the camera eye in Maxwell's field.
Right.
From that stationary perspective, the 0.4 c and 1.6 c apparent speeds are not illusions, They are undeniably real. They're inescapable mathematical facts of geometry.
The math doesn't lie.
Exactly. The gap between the light and the wall of the train genuinely closes at two vastly different rates depending on the direction.
Yeah.
And to the author, a theory that forces itself to ignore those basic mathematical facts just to maintain the elegance of a constant light speed is, by definition, a defective theory.
It's as if the author is accusing Einstein of sweeping the messy variables under the rug.
That's a good way to put it.
The implication is that Einstein didn't want to deal with the complex reality of a light beam interacting with the moving train at 0.4 c in one direction and 1.6 c in another.
Right.
So instead of dealing with it, he just declared by theoretical fiat that it's 1.0 c in all directions and called it a day.
That is precisely the accusation of slacking. The author believes Einstein took a shortcut.
Wow.
And, it encourages us to appreciate the brilliant mechanics of the critique itself. It shows how a single fundamental shift in perspective, moving from the relative experience inside the moving train back to an absolute unmoving camera eye outside of it, creates a mathematical discrepancy that is impossible to ignore.
It's glaring.
And it's a discrepancy that the author genuinely believes breaks Einstein's model of the universe.
It completely reframes the conversation around physics for me.
Yeah.
We spend so much time in science communication just accepting the tenet that everything is relative, right?
Sure.
That the observer's local experience is all that matters.
It is almost jarring to be forced by this document to look at a scenario from a rigid absolute standpoint. It's a completely different paradigm.
And when you do, the math undeniably produces these asymmetrical apparent speeds. The light is struggling to catch the front of the train at 0.4 C, and it is violently slamming into the back of the train at 1.6 C.
It raises one of the most profound questions about how we construct scientific models in the first place.
What do you mean?
Well, do we build theories that describe what observers happen to measure from their localized, moving, flawed perspectives, which is essentially what relativity does?
Okay.
Or do we build theories based on an absolute geometric reality, a sort of eye of the universe, even if we as humans can never physically occupy that absolute zero velocity position in Maxwell's field?
And the source document is planting its flag firmly and aggressively in the absolute reality camp.
Absolutely.
It is demanding we acknowledge the 0.4 C moving along the positive x-axis and the 1.6 C moving along the negative x-axis.
Yes.
It is demanding we distinguish between them, and it is holding up that exact distinction as the smoking gun that exposes the defect in special relativity.
It is a remarkably powerful thought experiment because it uses the simplest tools, like you said, basic subtraction in addition to challenge a profoundly complex theory.
Right, no calculus required.
It doesn't use convoluted multivariable equations that only a handful of academics can read. It uses the sheer, undeniable logic of two objects moving in a shared space.
The train chasing the light rushing toward the train.
Yeah.
The person walking backward on the moving walkway. It is so visceral, so easy to visualize once you detach your camera.
And it forces you, as a thinker, to justify why modern physics discards the absolute perspective.
You can't just ignore it anymore.
Right. If you are going to defend Albert Einstein against the claims in this document, you cannot just point to a textbook.
You have to do the work.
You have to actively defend the philosophical premise that the camera eye is an invalid way to measure the universe. You have to explain away the geometry. You have to articulate exactly why that 1.6 C apparent closing speed doesn't matter to the fundamental nature of reality. And depending on how deeply you engage with the author's logic, that is not as easy to do as one might think.
Which brings us right back to you, the listener. Because you don't need to be a theoretical physicist drafting peer-reviewed papers on Maxwell's electromagnetic field to appreciate the core lesson we have uncovered here today.
Not at all.
We just spent this entire deep dive unpacking a monumental clash of ideas, a literal challenge to the bedrock of modern science.
Right.
And the entire argument hinges on one single solitary factor, where you are observing the moving train from.
Perspective dictates the math. The reality experienced by the scientist inside the sealed train is fundamentally mathematically at odds with the reality recorded by the stationary camera outside of it.
And that is a concept that extends far beyond the realm of theoretical physics and light beams.
But definitely.
It is about how a simple shift in your vantage point can completely rewrite the established facts of a situation.
It really makes you wonder how many other systems, theories, or narratives we just accept as completely flawless simply because we're riding along inside the train with them.
Right.
Rather than, taking the time to step outside and watch them pass by from a stationary position.
That is a perfect way to frame it. Which leaves me with a final thought for you to ponder today as you go about your life. We started this whole conversation talking about bedrock. About the things we accept as solid, mathematically proven, and unshakable.
The foundational truths of our universe.
Right. And we just saw how a theory, as universally accepted and foundational as Einstein's special relativity, can be fiercely, intelligently challenged by simply doing one thing.
Just shifting the perspective.
Exactly. Shifting the perspective from the localized experience inside a moving train to a completely stationary camera eye, observing the whole system.
It changes everything.
So ask yourself this. What other universally accepted truths in your own daily life, whether it is a deeply entrenched routine at work, a long-standing dynamic in your personal relationships, or a core philosophical belief you hold about the world?
Right.
What might look completely different or even fundamentally flawed if you could just find a perfectly still, absolute vantage point to observe them from? What happens to your personal reality when you finally choose to step off the train, detach yourself from the motion, and look through the God camera?
The powerful question.
Thank you for taking this deep dive with us today. Keep questioning the bedrock.